Okay. So today, we are discussing a topic that is building on top of what we have been discussing in the last 4 or 5 lectures, which is inheritance, right? But before going into today's topic, I have a question for you. You remember the very first lecture we had in object-oriented programming for Java? What was the main, or one of the 2 main features that we said OOB is providing for us? Why OOB? What is the mindset here? Yep. Take advantage of. Yeah, I kind of see it. That's correct, but can someone add something? So what he said is, OOB provides you with a more of an abstract view of things, which is correct, right? But we said more than this. Yep. Exactly. It's modular and scalable. Why this is the case? Because the main mindset in object-oriented programming is you separate the interface from the implementation. You remember this? We said you want to protect your own members, your own data within the class, and then you don't want the user to know how you implement things. But on the same time, you want to provide something useful for your customer, right? So how to balance these 2 things? We said you implement whatever the way you'd like to implement your class, your project, but then you provide a contract to the user, right? This contract we call an interface, right? So you give the user, remember we draw this figure where you have a black box, and then you provide an interface to the user to interact with your own black box. What was at the interface? What did we call these kind of methods at the interface? If you have everything as private members inside the class, how the user can interact with these things? We had a special set of methods to deal with this. Yep. Yeah, getters and setters, right? So we said the getters and setters methods are at the interface to provide the user with the ability to modify or read the member variables without knowing how we implemented them, right? So today's topic is on the same mindset. So you have to put this in your mind. This is how OOB mindset is developed. You want to protect your data, and also you want it to be modular and extensible by providing a way to separate the implementation from the interface. Good? And then we build on top of that by saying, by just having this, you also can have classes, projects, and then later you can create childs out of these parents, right? And this was the main thing about inheritance. You have one implementation of a certain thing, and then later you can derive classes out of this, right? And then we said the reason for this is you can have shared features among multiple classes, but then each one of them will have its own features as well. How you can handle this? Using inheritance, you define your own parent class, right? That has all the common features. And then later, you have the childs out of this parent, and each one can implement these members, these methods, or these features. Good? This is the mindset that we are moving in our object-oriented part of the course. Good. Today, again, we take it one step further by saying, one of the main features that you inherit from your parent class, one of the things that are usually common among childs of the same parent is the interface, right? So you can have an interface that is common among multiple classes, but each one of them implements it in its own way, right? So remember yesterday we had the graphic object class, right? That has the area method. And then really the graphic object had no area because graphic object was nothing, right? It wasn't a rectangle, circle. It wasn't a shape that you can have an area for, right? But then after that, we drive childs out of that, like the circle class, that rectangle, the triangle ones, and then each one has its own version of the area, right? Remember that? So by doing that, if you think in this, clearly we didn't say this yesterday, but if you think in this, the graphic object, the parent class, the superclass, it doesn't care how you implement area in the superclass because you will never use it in the superclass, right? Why not just, we didn't say how we implement it because we really didn't implement it. We just left it empty, right? And then to do this, what I mean by empty is you didn't have a body for the method, right? You just wrote the method type, but you didn't have a body implementation at the graphic object to implement the area, right? Because we said for the circles by r square, for rectangle it's x multiplied by y, but for the graphic object, the parent one, this is not a shape. I don't know even how to define the area for that one, right? But it has to have a method that is called area. So this kind of method we call an abstract method. Why abstract? Because it's a method that is defined at the parent, but is not implemented at the parent. Again, the mindset is you separate the interface from the implementation. So we define the interface at the parent class, but then you implement it your own way based on the shape that you derive out of this class. Is that clear? Good. So here, basically you inherit the implementation as a child. You implement the implementation of methods, but also you implement the interface. So you inherit the interface, right? And if I inherit the interface, I can implement it my own way, right? So we call these kind of classes, first of all, we call these kind of methods abstract methods. And then any class that has at least one abstract method is going to be an abstract class. What do we mean by an abstract class? It's a class that has one or more methods that is not implemented, just provided at the parent for sake of defining an interface, for sake of defining a contract between you and the user. And then later, the child will have to adhere to this interface, right? So one example here is you can say, I'm going to define a class that I call shape, and it's an abstract class. It has one method that is called area, just returns 0. One method that is called volume, it returns 0. But then it has an abstract method that is called getName. So as you can see here, you can have multiple methods. Some of them are abstract and some are not. And given that you have at least one abstract method, then your class has to be defined as abstract, right? So in Java, you can leave a method without implementation in the class under the constraint that you define this method as abstract and the class that contains this method as abstract as well. So for example, in this case, if you have this implementation, but you don't put abstract reserved word here, it will give you a syntax error, it will not compile. The reason is you have one method without implementation. Then it has to be an abstract method and the class that is containing it has to be abstract as well, right? Is there any question? Good? Yep. You mean here and here? So this one is for the method, right? So you define a method here without implementation, right? So you see area and volume has already a body that implements what is the area. Even if it's a single line, it's still an implementation of the method, right? But for the getName one, it doesn't have any implementation. Then this has to be an abstract method. So this abstract word is for the method. But then if you have, as I said, at least one abstract method, your class has to be abstract as well. So this is defining this class to be abstract. This one is defining the method to be abstract. Right? Is there any other question? Yep. Okay. So what are the differences between abstract class and a normal class? Like so far, like in our last 7-8 lectures, we interacted with classes and we didn't call them abstract, right? These were called concrete classes. What do we mean by a concrete class? It's a class that has all the methods implemented in that class. You don't leave any method without implementation. Good? So the main difference between abstract class and a concrete class is previously we were able to instantiate a class. What do you mean by instantiating a class? Yep. Yeah, create an instance of this class. Define a variable, create an object in the memory out of this class. This is called instantiation, object creation, or this is used, like you can use the new reserved word for that, right? Abstract class, you cannot create objects out of this class. Can you imagine why this is not the case? Why it makes sense that I cannot create an object out of the abstract class? So think in that. Once you create an object out of the class, you are able to access the methods of this class, right? Then, for example, here, if we go back, if I assume from now, if I'm able to create an object out of this shape class, I can say, and I call this my shape, right? So it's an object that is called my shape. In my main, for example, I can say my main.getName, right? Because this is a method that is public. I'm able to access it. I'll say my shape.getName, right? But getName has no implementation, right? And we know that because it's an abstract class, it's an abstract method, it has no implementation. So what does it mean to say my shape.getName? You cannot do this, right? This is why you cannot create objects out of your abstract class, because once you create an object, you have access to all the methods, right? But you have some methods without implementation. So if you access them, what is going to happen, right? This creates an odd situation, right? So you have to know that abstract classes you cannot instantiate, but concrete classes, we have seen this before, like multiple times, you can create objects out of them. Right? So another thing is, you can create an abstract class, and actually we said the main mindset is you can create an abstract class, and the reason for this is you want to define an interface later that you are going to implement this interface in a child class, which means it makes sense for an abstract class to always have a child, right? It's not a rule, but it's the common use case, right? So you have an abstract class, and it can have a subclass out of this parent class, right? You can have an abstract class, you cannot instantiate, but you can still inherit its features, implement it. Then the child can be a concrete class. Does this make sense? I have a parent abstract class. I created a child that extends this abstract class, but I implemented all the methods inside my child. If you implement all the methods, your class is concrete, right? So that means now you can have a concrete class that is a child of the abstract class, right? What about the other case? Can I have an abstract class that is a child of a concrete class? It's based on something we discussed yesterday. Assume, for example, here, this shape class. This is an abstract class, right? Yesterday we said all classes by default are childs of what? Yep. Yeah, the Java object class, right? So yesterday we had this figure where all the classes by default are extending the Java object class, which is the parent for all classes, right? But this one is abstract. Yesterday, the Java object class was a concrete class, right? Which means now you can have an abstract child out of a parent concrete class, right? You can have both cases. But why it makes sense that I can have an abstract class that is a child of a concrete class? Because we know that from inheritance, a child class can have its own methods, right? And then some of these methods can be abstract, that didn't even exist at the parent, right? Make sense? So as a child, I define my own method, but this method happens to be abstract, and then I have to be an abstract class, but my parent, all the methods were concrete, so it's a concrete class, right? And the clear example here is the object class again. It's concrete, but you have also some abstract classes. All of them are childs of the object class. Good? Is there any question? Yep. That's an excellent question that I was saving for you, but given that you asked it, so your friend question here is, what is the point? Let's jump into what you said right now, right? So yesterday we had this, right? But these were concrete classes. This had an area method, and then everyone implemented its own area, right? Then now we said this graphic object can be abstract because you don't implement the details of the area method inside your graphic object, which means it's an abstract method. And then the class itself is abstract, and all these childs will implement the area, right? So now we modify this such that this is an abstract parent, and all of these will implement the area thing. And the abstract parent will implement an abstract method that is called area without implementation. Then comes your friend question here, which is a fantastic one. Why even do I have this one? Because I can have a case where I don't have an area method in the parent, and I only have it as a child. Because we know from inheritance that a child can add whatever method it wants to add, right? So why even bother having an area method as the parent, given that I don't have an implementation for that? Can someone think in an answer for that, based on what we discussed yesterday, for a bonus mark? There are two reasons. If you just mention one of them, it's a bonus mark. Yep. You are close. Yeah, maybe I'll count this as an answer. So what he is saying is, you can define, he said it in maybe the wrong terminology, but what he means is you can define, we said you cannot create objects out of an abstract class, but you can still declare references out of them. If you remember from yesterday's example, we had in our main, we created an array of graphic objects, right? Like the G array. And then later, we called the array elements.area, and then we said it's a fantastic way of polymorphism where you can call whatever area you would like in the runtime, which is dynamic binding, right? If you don't have an area method at the parent, which is abstract, you will not be able to do this, because at the end, any array entry is of the type parent, of graphic object. It's not rectangle, it's not triangle, right? You don't know this. You are defining this as the graphic object type. So if you have something that is graphic object type and you say dot area, but it's not defined there, you are not allowed to do so, right? This is one reason. And we will come into this in the example right now. The second reason is, can someone imagine why it's useful to have an abstract method at the parent if we don't implement it? It starts from what we started this lecture with, which is the mindset of OOP. You want to enforce a certain interface, right? This is what we said. You need an interface between you and the user. You need a contract, and then later the detailed implementation of this contract will be child dependent, right? But if you don't have a method that is called area at the parent, then what will force my rectangle or my point or my triangle, my circle, all the childs here to implement a method that is called area? Nothing, right? If you really have a method that is an abstract method at the parent, you can also not have it at the child, right? Maybe I'm not forced to have an area method. You can create a class which is completely correct syntax. If you, from yesterday's example, this wasn't an abstract one. We didn't have an area method. I can create my rectangle class without defining a method that is called area, right? Make sense? But if your parent is abstract and it has an abstract method that is called area, you have to implement this method as a child. Otherwise, you are also an abstract class, right? Remember, from inheritance, the child will inherit everything from the parent, right? Including all the abstract methods. Make sense? Then, we have two cases. You either implement it, and then you will become a concrete class, or you don't implement it, and then you have to declare yourself as an abstract class. So if you don't implement the area, and you don't define yourself as abstract, you will get a syntax error. This is a way from the language to enforce the child to implement the interface, the contract between you and the user. Right? So these are the two main things why defining an abstract method that's called area as the parent is useful. Right? The first one is, as we will see now, you can create general objects that use this area method. The second one is you are forcing your child, if they want to be concrete classes, to implement the area method. Right? Good. Is there any question? Yep. Yeah. So an abstract class is a parent class. All the inheritance rules will apply. You still are able to cast a child to a parent. But remember, from inheritance, if you are casting a child to a parent, this doesn't mean that the parent object has access to all the methods, right? So in this case, it will not have access to the implementation of the area because it's still an abstract class, right? Good. So this is what we were discussing right now. And this was our yesterday example. We modified it to have our graphic object to be abstract. Now in our main, we define the array as elements of the abstract graphic object. And then later we take, as we have done yesterday, you take each 5 elements, each one of them would be one of the childs, right? And then later you calculate the largest area. By the way, did anyone try this at home yesterday? Yesterday we had only one. Did anyone try yesterday? Would you please raise your hand? No? Again? Okay. So here we calculate the largest area, and then as we have said yesterday, this is the dynamic binding thing. GI is an abstract graphic object type, but you can still refer to GI.area because dynamically at runtime, based on what is GI here, what is this element, whether it's a circle or a triangle or a rectangle, you are looking into the correct implementation of the area. One question I have here. We said you cannot create objects out of an abstract class. But in this line, I say abstract graphic object, GObject equal new something. It seems like I'm creating objects of an abstract class, right? What do you think? How this is allowed? Like 5 minutes ago, I told you cannot create objects out of an abstract parent, right? Abstract class. But here I'm using the reserved word new, and we know that new reserved word, you create objects at memory. This doesn't seem correct. What do you think? Yep. You create references. So yesterday we said you create references or you define references by declaration, not by the new reserved word, right? So if you want to just create references, you would say abstract graphic object and then my object without saying equal new abstract graphic object, right? So my concern here was the word new. By the way, what you said is correct, right? But you miss the most important part of the answer. Why I'm using, if I'm creating references, in creating references, we don't use the new reserved word. Why I'm using the new reserved word here? Exactly. So this new is for creating the array, not the objects of the class, right? And this is very confusing, right? So remember, arrays also in Java are just objects, right? Then to create an array in memory, you have to use the new reserved word, right? So this new is just creating the array space in the memory without creating the objects, which is the entries of this array. Later, we use the new reserved word to create these objects as part of the child, right? You need to make sure this is like a tricky thing that you need to understand. Is there any question? Okay. So we already discussed this. If you are a child of an abstract class, and then you don't implement all the methods that are declared abstract as the parent, then you have to be abstract as well, right? Otherwise, you can be a concrete class if you define everything. The other important thing, and this is an important difference between abstract classes and something that else we will discuss also at the end of this lecture. As an abstract class, you can still have member variables, right? So here in the shape abstract class, come on. So, actually we didn't have member variables here, but you can say, for example, int x equal 2, or int y, or any member variable, right? Abstract class is still a class at the end, right? So you can have member instance fields, and also you can have concrete methods as part of the abstract class, right? The rule is abstract class has at least one abstract method, but maybe you have all other methods as concrete. Again, for the shape one here, you have 3 methods, only one of them is abstract, the remaining 2 are concrete ones, which means they already have a body implementation, right? Good. Okay. We already said this, you cannot create objects out of an abstract class, but you can still have some constructors. How would this be possible? We said a constructor is being called once you create an object out of a class, right? But if I cannot create an object, then you cannot have, or you will not call a constructor, right? Why here I can still have some constructors? What is the other case where you will be calling a constructor by default? And this still applies to abstract classes. We discussed this before, and it's a bonus mark. Yep. Exactly. We said if you are a parent class, and then you create an object out of a child class, we know that once you create an object, you call the constructor. The first line that is being executed at the constructor of the child is, what is that? The constructor of the parent, right? So here, even if you are an abstract class, your child can be concrete. And if it is a concrete class, you can create objects out of that. And if you create an object, you are able to call the constructor. And the first line that is being called at the constructor of the child is the constructor of the parent. So you still need constructors, right? Good. The other rule for declaring something as abstract is constructors cannot be abstract. Makes sense? Because if it is an abstract method, you have to implement it somehow, but constructors are being called by default the first time you call something, and you call them to initialize values, right? And the other thing is static methods cannot be declared as abstract. Why this is the case? Again, from yesterday. Why I cannot declare a static method as abstract? Do I have to say it's a bonus mark for someone to answer? You guys should be generous. Why I cannot create a static method as abstract? Maybe I just go one step back. What is a static method? We revisited this yesterday. Yep. Yeah, the first part is not correct. We don't initialize a method, but what you said later is correct, which is it exists in the memory once you define it and remains there forever, right? Then, again, yesterday we discussed if you have a static method at the parent, and if you redefine this method at the child, you are actually creating another method, right? We don't override static methods. So if you have an abstract static method, you will not be able to implement it at the child, right? Because if you create the same method as the child, it's not going to override it, right? There is no overriding for static methods, and that means you cannot create an implementation for a static method. Then if you cannot create an implementation for a method, it cannot be abstract, right? Because abstract method, by default, you have to implement them later, right? Make sense? Okay. The other thing, and it's kind of a weird case, it's supposed to declare an abstract class which doesn't have any abstract method. We said if there is at least one abstract method at the class, it's an abstract class, but we can still declare an abstract class, a class as an abstract, without having any abstract method. Makes no sense, right? And in this case, you cannot even create objects out of this class. The same question is why I cannot create objects of abstract class that doesn't have any abstract method? Because if you don't have any abstract method, then you already have their implementation. You will not be implementing them. That means you cannot have a concrete child out of an abstract class that doesn't have any abstract method, right? Is that clear? Is it too confusing? A subclass can be abstract even if the superclass is concrete. We already discussed this. Okay, so let's keep the quiz for now. And let's jump into something that is related to abstract classes. Again, we are still at the mindset of separating the implementation from the interface. Java has another capability for you as a programmer to create interfaces without implementation. Abstract classes are one of these capabilities, right? Another type of, you can think of another type of classes, but it's not actually a class, is called interface. So there is something similar to a class. You can create an interface separately, and this is called interface, reserved word we will see right now. And in an interface, you are just defining the interface of your black box, right? You don't have any implementation. There are some subtle differences between interfaces and abstract classes that we will see right now, but the mindset is still the same, right? You want to separate the interface, the contract between you and the user, from the implementation that you are going to add later or modify later, right? So, yeah, so this is a contract or a protocol between you and the user. And then in an interface, you just declare certain methods without implementing them, completely similar to an abstract class, right? And then later, another class would be implementing these methods, right? So we'll see some rules and then we'll see examples to really understand these rules. All methods in an interface, they have to be public and abstract. Makes sense, right? An interface, you don't have any implementation of any method. So that means now all methods in an interface are abstract, right? So this is the first difference between interface and abstract class. Remember, like 10 minutes ago, we said an abstract class is abstract only if you have, or at least you have one abstract method, but you can have all other methods as concrete ones. You can still have some implementation in the abstract class. In an interface, it's not the case. All methods have to be abstract, right? You cannot create any concrete method in an interface, right? So yeah, an interface is not allowed to contain instance fields. This is another difference. We said in an abstract class. So okay, if you are confused, you can think of this like the following. Abstract class is just a completely normal class, except it has one or more abstract methods. A method without implementation. Good? It can still have instance fields, members, concrete methods. It can be a parent class, a child class. Everything applies from a normal class definition. Good? On the other hand, for interfaces, it's a completely different thing. All methods have to be abstract and public. You cannot have any instance fields or members, right? And if you don't have any of this, that means you cannot have constructors that initialize them, right? You just define the border of your project, right? Like the actual interface itself. Okay? So we changed our shape abstract class to be interface. Then, as you see now, all our methods are public abstract, so like the area and the get name. And then you cannot have any instance fields, but this is not an instance field. This is a static member. You remember, static variables are not instance fields. Static variables are just existing in the memory all the time. And then they have to be final as well, which means they cannot change later, right? So given that this is a rule, which means all members are, if they are variables, then they have to be final and static, or if they are methods, then they have to be abstract. Then you are free to remove the specifiers here, because it's known by default. Once you define something as an interface, you can just say end k equal 1, and the compiler knows that k is a public static final integer, right? So the second most important thing that you want to see here is, here we didn't use the word class at all. Maybe this is the very first time since we moved to Java that we can write something without a word class, right? We are using the reserved word interface. Good? In the Java virtual machine, which is the infrastructure that is executing your code, the interface is being translated later to be actually a class bytecode, right? But so internally it's a kind of a class, but it's a different kind of class, right? But here you just define it as an interface, and then everything here is without implementation. Again, if I don't implement things, what is the benefit of having this? Why I would have something that, like, what is the usefulness of this piece of code if it doesn't have any implementation. If you try to run it, nothing will happen, right? So why it's useful? Someone else? You guys need a quiz to be refreshed? Yep. Again, this is defining the contract without implementation, and later you implement the interface, right? So it's useful because you define your contract and then later you implement it. The mindset is you separate both, because if you want to modify your code later, make it bigger, make it better, or add something for security, then the implementation is separate from the interface. This interface will remain the same, but how you implement area and get name would be different, right? Good? Okay. So let's see some examples of interfaces, right? So remember our circle class that extended point from like 5 lectures ago? We had a point class that defines coordinates of x and y. Then we defined another child circle, right? That was a child of the point. Now, the way you implement an interface is you say, so for inheritance of classes, you use the reserved word extends. But for implementing an interface, you are using the word implements. That means now, to understand this line, you are defining a class that is called new circle. This is a child of another class that is called point. But also circle is implementing an interface that is called shape. Generally, you can have a class that is a child of another class and it implements multiple interfaces, right? One big advantage of interfaces compared to classes, and this maybe you kind of wonder why I need an interface if I can use an abstract class, right? Yesterday, we said one limitation of Java compared to other object-oriented programming languages is what? Something related to inheritance. Yep. Yeah, exactly. You can define a child of only one parent, but you cannot extend or be a child of multiple classes, right? We said this is allowed in other languages. In Java, to make it easier to program, you don't have multiple inheritance, right? This rule does not apply for interfaces. You can have a class that implements multiple interfaces. As we see here, it implements interface 1, interface 2, interface 3. So this is a way to get around how to inherit multiple features, right? Because if you define these features as interfaces, then you are allowed to inherit them from multiple interfaces and then later implement them. Good? So, given that I guess we will not have a time for our quiz, you guys are happy. Maybe I'll ask you to implement this example and let's discuss it, right? Yeah, fine. Yeah, you have to have one. If they have the same method name, you're going to implement only one of them. Or we'll come into this. Or you will have to refer to interface one dot certain method interface. But we will come into this, right? We'll come into this. So you guys, please implement this code because we will discuss. We'll look into the output of a certain thing. So will it be possible to define this interface and then define this class that implements this interface? I'll give you 2 minutes for that. This, you mean this one? This one will not be abstract, right? It has to be concrete because you are just implementing. So here we are not doing anything with abstract classes, right? We are implementing an interface, right? have a question? Are you guys done? Who is done? No one is done? Yeah. Okay, so if you are done, then we would also add this method, which is the getName one. And then, okay, and then forget about the circle one. Or you know what, maybe. So, okay, so if you are done with the rectangle implementation, you implement a new circle class, but it is one, you guys already have this from our point circle. I assume you implement this already, but don't extend the point class. For those who doesn't have the point class implemented from our previous lecture, don't extend the point class, just directly implement the shape interface. Do you see what I mean by this? Previously, we had circle that is extending point. If you already have it, I told you before that I have a folder that implements like all the lecture examples we have. If you already have it, then feel free to write this code. If you don't have the point class, just to save your time, don't extend the point class, just make the new circle class implementing the shape interface. Okay? You also have like 2 minutes for that. Okay, so if you see from what we are doing here and here, so we are already implementing the methods of the interface. For the area one, for the rectangle, the length multiplied by the width. For the getName, we just return a rectangle string, right? For the circle, we do exactly the same thing. We return the by r square, the area of the circle, and the getName, it would be a new circle class, right? This super AB thing would only work if you already have the point class, but you shouldn't be writing this if you don't have the point class, right? Because we know that super here is calling the parent class. Great? Okay, so if you have this, then now it's time to test it, right? So we have an interface. We have 2 separate classes that are implementing this interface. We want to write a main method, another method that instantiate some shape interface and some circle and some rectangle classes, right? So you have 2 minutes, 1 minute to write these 3 lines of code, and then later let's discuss them, right? How to test whether this code is working or not? Then you print the sum, right? What we do here is we create a rectangle and a circle objects, and then we add the areas of both, right? Then the sum would be the area of the circle plus the area of the rectangle, and then you print it. If it prints correctly, that means you did the implementation correctly. Okay? Maybe you let me know what is the output. Okay, I'll not be able to check, but yeah, so you kind of calculated the area and the area here and you printed it down. Okay, good. Did anyone else got it working? You were able to get the sum of both areas? Is there anyone else done? Yeah? Yeah, what is the output you got? Okay, good. Anyone else was able to get it? Yeah? Okay, okay, okay. Okay, so now what are we doing here, right? First of all, you create an array of interface shape. The same question that I asked before for abstract classes. You cannot create objects out of an interface, right? But here, you are not creating the object, you are creating the array itself. So we are creating an array of two elements. The first element is a rectangle class, and then we initialize it, the length and the width. And then the second entry is the circle class, right? Which is initializing x, y, and the r. And then you do the sum. In the sum, you say area 0.area plus array 0.area and array 1.area. What do we do here? So again, the elegant thing about polymorphism is you had an interface that had an area abstract method without implementation. Later, you implemented it in two different ways. During runtime, you are able to call the correct method that implements this interface, right? For the first one, it calls the rectangle one. For the second one, it calls the circle one, right? You calculate the correct area and then you add them up. What did we call this? This had like a terminology, it had a name that to know which, yeah. Dynamic method binding, right? So it's dynamic binding. During runtime, you know which method that you are calling, right? Is there any question in this code? Okay. So the same thing applies here. Is originally you defined the array entries as shape, but then later you assign rectangle objects to them. Why this is allowed? It's the same reason from inheritance, is you can assign a child to a parent, and this is called, what is the name of this thing? Called casting, right? You cast a child to a parent, similar to casting an n to a double or a float to a double, from a narrower field to a wider field. Good. So let's conclude with this, some other casting examples here. This is exactly the same thing that we had before. Now, the fourth line here is the interesting one. We define an object, or first we declare an object that is called rectangle R, and then we say it's equal rectangle array 0. Why this is allowed? Why I can do this? Because array 0 is of type interface, right? Originally it was interface, but now I define the object as rectangle, and it's okay to take it, to cast it from